All right, so now let's take a look at the right way of doing things, or how to incrementally adopt the right architecture if you're running some of the patterns that we've discussed before. It's often easier when you're trying to move to this direction to solve the east-west problems first, and then tackle the north-south. So the main ones that we want to solve for east-west is first, let's tackle the hairpinning of traffic around API gateway, and for that we'll leverage a service mesh. So we'll leverage Istio on let's deploy Istio on both clusters, and we're going to run in Istio ambient mode. So what Istio will give you is the ability for this application, when it calls this other application, this traffic will be mTLS, right? So immediately out of the box, you get full identity from service A talking to service B. You don't need to go around the API gateway when this traffic is talking directly, because this gives you significant amount of policies straight out of the box, especially around authentication and authorization. So you can create policies on who is allowed to talk to what. If you need advanced API gateway functionality, if you need to do things like authentication with an external auth provider or rate limiting or anything like that, then you could deploy what's called a waypoint. So a waypoint is a transparent proxy that Istio will deploy and manage for you. And now that gives you the ability to deploy more advanced policies. And this waypoint acts as a micro gateway to one or more of your services. So you can selectively choose which services need a waypoint and then deploy that waypoint, and then traffic it seamlessly traverses through that waypoint and becoming your policy enforcement point. So what this will get you is the ability to route traffic efficiently from one service to another service. When you're doing cross-cluster traffic, when this service wants to talk to this service, Istio can run in a multi-cluster mode where traffic can transparently traverse your network and reach the destination. So if you're on a flat network, it can go direct. If you're not running a flat network, if both of these clusters are on their each independent networks, then we can transparently route the traffic through what's called an east-west gateway. Again, that becomes an implementation detail, but from this service perspective, it can call services in another cluster, and that functionality is provided to Istio because Istio does service discovery amongst each other. So the Istios in all the clusters talk with one another and they exchange service discovery information, which allows traffic to use Kubernetes-native host names to send traffic, to resolve DNS and send traffic to wherever it needs to go. So it's a very powerful architecture, and we're not relying on hairpinning of traffic around an API gateway for east-west capabilities. So we talked about zero trust, right? Once you adopt this architecture, you can start writing authorization policies on who's allowed to talk to what, and enforce additional policies using a waypoint as necessary. All of the configuration here, when you're writing these policies, when you're writing like authentication and API gateway policies between service to service, does not involve another team. You're writing Kubernetes-native configuration. You're using Kubernetes custom CRDs. So all of these configuration can be packaged inside the same Helm charts that developers are using to deploy their application. So everything over here is fully Kubernetes native, and you get self-service, and you're using Kubernetes native CRDs and open standards like Gateway API. Best of all, you get full observability, right? So when whether traffic is going from one service to another in the same cluster or between clusters, you have the identity and the source and the destination identity of all the services, which gives you full observability so that you can do problem determination if anything goes wrong, right? And now next, let's tackle cost effectiveness, right? So now that we're no longer going through the API gateway for all east-west traffic, it significantly reduces the cost and the amount of resources that the API gateway needs to run. We can actually take it a step further. Just like our east-west traffic have full capabilities to route in the same cluster as well as to remote clusters, we can bring that gateway functionality to the clusters by deploying an Istio Ingress gateway or some sort of Kubernetes native gateway like kgateway. And this gateway acts as the API gateway for that cluster. So instead of traffic going to the external API gateway, we can send traffic directly to the Ingress gateway of that cluster. And because these Ingress gateways are part of the mesh, they get the same advantages that the service mesh provided for each of the services. So this gateway can route to the local cluster as well as route to remote clusters. This allows you to get HA. You can deploy the same instance of a service on both the clusters, or you can deploy an instance of the service in a remote cluster and not on the local cluster. You can run Canary deployments of a service in Canary clusters. So this opens up a whole world of use cases so that you can do HA, Canary routing, and any type of advanced routing that you want to do. And then once you have this system where you have your layer 4 traffic coming directly to the clusters and doing cross-cluster routing, you no longer need this external gateway. So you can get rid of, you can entirely just get rid of this entire stack and have the traffic go directly to the clusters and provide developers the full self-service capabilities. If you're interested in learning more, contact us at solo.io.